Okay, pre-calc. So our next section in chapter 11 for Introduction to Calculus is going to be about derivatives. We're going to break this into 3 different videos. So today is going to be video 1, and it's going to be all about how to find derivatives and the definition and a formula for how we find the derivatives. It's going to be very similar to something we did earlier in the year that was called the difference quotient. So first of all, finding the derivative of a function is found just like the slope of a tangent line, which we'll actually see in our next video. And our definition of a derivative we use right here, which we term prime. So we'd say f prime of x is called the first derivative. We can also have the second or third or however many derivatives we want. Each additional derivative just adds an extra prime. And that's going to be the limit as h approaches 0 of f of x plus h minus f of x over h. So you notice right now we can't do this because we can't plug 0 in for h. And so what finding our derivative does by doing this x plus h, and we'll explain this a little bit more in the next video too when we talk about secant and tangent lines, but essentially as h approaches 0, these 2 points are getting closer and closer to 0 as well, meaning their distance between the 2 points is becoming infinitesimal, or meaning it is virtually nothing. There is no difference. So we're trying to figure out what happens when these 2 points become the same point, more or less. And so what we need to do is simplify our f of x plus h, meaning we're going to plug in x plus h everywhere we have an x, and everything should disappear that has only an x so that our h's cancel out. Big thing here, we are trying to have the h's cancel out when we do our first derivative, so that then we can just plug in 0 for h and we'll be left with f prime of x, or the derivative of f of x. What that would look like is if I have some function f of x equals x squared plus 3x, and I want to find the derivative. So if I look at my formula that we just had there, h approaches 0 of f of x plus h minus f of x, the whole thing over h. And you need to remember, we did this without the limit earlier in the year, called difference quotient. We struggle with this f of x plus h a little bit. This means everywhere you have an x plus h needs to be plugged in. So I'm going to look at my function, and right here, instead of x, I need to have x plus h squared, plus, again, right here I have an x, so I need to have 3, and then in parentheses, x plus h, minus, and I'm going to put the whole f of x in parentheses here because you're going to have to distribute that negative sign, the whole thing over h, and we should actually have the limit as h approaches 0 in front there. Okay, so we've got some algebra to do here to simplify. As long as you're careful with your algebra, you won't have any problems with this. So again, the limit as h approaches 0, and I'm going to do my algebra now. I'm going to take x plus h and square it. That's going to give me x squared plus 2xh plus h squared. I'm going to distribute my 3 here, so plus 3x plus 3h, and distribute my minus sign, so minus x squared minus 3x, and the whole thing is still over h. Okay, so that's the first step in finding the derivative. Now, a big thing that we want to find here is that things with only an x term should disappear as long as we've done our algebra correct. So we have an x squared and a minus x squared, so I know those 2 are going to cancel out. I also have a minus 3x and a plus 3x, so I know those 2 are also going to cancel out. And if we rewrite our terms now, you'll notice that each term in the numerator has an h. And what that's going to allow us to do, and I'll show you here, is factor an h out of the numerator, which would leave me with a 2x after I factor out the h, plus this is going to have 1h left, plus 3, and the whole thing is over h. And now, because I factored out that h, I can cancel those out, and so I have the limit as h approaches 0 of just 2x plus h plus 3, and now I can plug in, because I'm not dividing by 0, h, and that's going to end up with 2x plus 3, which means that first derivative f prime of x equals 2x plus 3. And that's going to be important for the next piece that we talk about. So that's how we found the derivative of a function, 2x plus 3. The next piece then is if we ask you to find the derivative of a function at a specific point. So you notice we have the same function here, and if we had done the work that we just did, 2x plus 3, now to find x at x equals 2, really you're just being asked to find f prime of 2, and so I could take my f prime of 2 and plug it in, and I would end up with f prime of 2 equals 7, because 2 times 2 is 4, and 4 plus 3 is 7. Okay, and that is it for how we find the derivative of a function. We've got that big long formula, which really, again, is just like something we did the first semester called the difference quotient. Now, as long as we're careful with our algebra, we shouldn't have any problems with this. See you next time.